Number 9 will add an additional component to our graphs. That 3 on the outside of the radical, that tells us there will be a stretch of 3 units. We also have a +1 underneath the radical, and we've seen that before. That's telling us to shift everything to the left one. So when we have a stretch or a compression, using the pattern is a very quick way of graphing. Since I'm moving this whole graph to the left one, and I don't have any let's try that again, I don't have any k values at all, there's no +1, +2, +3 on the outside of the radical, our endpoint is going to be -1, 0. Again, the -1 is because of this h, this left, but I don't have any plus or minus on the outside, so we're going to have a y value of 0 for that starting point. So let's plot that, -1, 0, which is about here. I'm going to use the pattern method of graphing because it's very quick. If we go back to our parent graph, remember there's a pattern that all these points follow. Up 1 over 1, up 1 over 3, up 1 over 5, and then it would be up 1 over 7, up 1 over 9, up 1 over 11, so on and so forth. It's a pretty quick pattern, but now I'm stretching that by 3. So instead of up 1, I'm going to go up 3. 1, 2, 3, and over 1. And then I'll go up 1, 2, 3, and over 1, 2, 3. And then I go up 1, 2, 3, and over 1, 2, 3, 4, 5. And if I had room, I could go up up 3 over 7, up 3 over 9, up 3 over 11. We're just stretching this interval between points. They used to all be up 1, now they're all up 3. So using the pattern, remembering that pattern, all those odd numbers, will really help you to graph these things quickly. Connect the dots, and we've got a nice stretched radical function. Not too bad. Notice that the domain is no trickier than it was in the past. This is going to be all x values greater than or equal to -1, because we start at that -1, and then we move to the right. Our range is going to start at 0. Our smallest y value is 0, and then as we look up, we get all the positive numbers. And then we can also look at that end behavior. As x gets really big, so does y. That's what the arrow's telling us. And as x goes to -1, as we get closer and closer and closer to that end point, then y goes to 0. Again, we don't really look at the increasing and decreasing here in AB, but if you look at the function, it's always increasing. From left to right, this thing's always going up. So take a look at this one. See if you understand how that stretch works. If you can find those next couple of points, feel free to try a random example if you'd like. You want to throw something down there in the 4th quadrant. Maybe try something with a stretch of 2, something with a stretch of 4. Or go ahead and work on the problems that are assigned there at the back of this purple packet. See you next time.